In this video, I also want to teach you about another approach by using matriculation program statistical table. So if you observe that for the binomial distribution table, the values, the value of p's, as you know that the number of sample, the maximum number of sample that provided by this statistical table will be 50. There are no value, the number of sample beyond 50, 51, 55, there are no, it's not provided in this statistical table. And also the probability above here, the maximum value provided by this statistical table is 0.5, right? It's 0.5. So means there is a limited that you want to using this, alright, statistical table here. So, okay, there is another idea. Let's say if you want to using this statistical table, if you having a value of probability distribution, a binomial distribution with 30, alright, 0.7 for example, 30, 0.7. Okay, 30 is okay. The number of sample 30 is in this statistical table, right? 30. So if you look at this 30, which is in this statistical table, right? 30, 0. But there is no 0.7 here. That's the problem here. This is what I want to talk about in this video here. So there are no 0.7 here. Maximum is 0.5, but there is a value of n30 here. So what you can do is you can do some transformation. All right, you can transform the distribution to another distribution. X is the number of success, right? It's a number of success. So we can transform it into a failure. Means that success and failure, right? So means there is a number of 30 sample, right? 30 sample. So we can also write as binomial as 30 sample, but with the probability of 0.3. 0.3. Event X and event Y are complement to each other, right? They are complement to each other. So as you see that 0.7, right? This will be 0.7. So 0.7, 0.7, and this is 0.3. If you total up these two, it will be 1. If this is 0.8, which is not, you cannot find in your table, so you are using 1 minus 0.8. If this is 0.8, this will be 0.2. If this is 0.6, this will be 0.4. Total must be 1 because it's either for binomial distribution, there are two types of outcome, which will be win or loss, right? Success or fail. So now, okay, how to using this statistical table if you have this case here with 0.7. So, for example, you must always know that, understand that the total, you know that X is the number of success and Y is the number of failure, right? If you have 30 games, for example, you have 30 games, you play 30 games, okay? You have 3 permainan. So one game, it can be either win or loss, right? Win or success or failure, right? Win or loss. So the total number of games, either number of wins and the number of loss must be always 30. This is a very important relationship here. So you have to remember. So means that you can describe, you can convert the X to be 30 minus Y. Means that X is actually the same as 30 minus with Y. Okay, at first you have to understand this because the total number of success and total number of failure will be always 30, right? It's always 30. So, okay, let's say if I ask you to find at least 12, right? At least 12, probability of X at least 12. There is a problem here. There is a problem. What is the problem? Because if you want to use the X distribution for X, which is 30 and this is 0.7, you can't find it in your statistical table, right? Because you only have 30, maximum is 0.5. So then you have to consider this distribution is the same, right? So okay, then you have already know that X plus Y will be 30, right? It will be 30. So what you do is, you know that X is 30 minus Y. So you can convert this, because you need to use this distribution 0.3. 30, this is 0.3. This is in your statistical table. That's why I convert become this. So my variable here, x, I also have to convert become y. So you look what I'm doing. So the x here, I will change become 30 minus y. 30 minus y, right? So as you know that x is 30 minus y. So which is at least 12. Is 12. So slowly I'm doing. So 30 minus 12, I have the value of 18, right? 18 greater or equal, negative y move to the other side will be greater or equal y. So I can rewrite this as y at most 18. At least 12 success is the same as at most 18 failure. So later on, if you want to using the statistical table for this distribution, is 30 and 0.3, right? So you find for the value of 30, okay, 30, 0.3, right? 30, 0.3. So where is 30, 0.3? It's around here, right? It's around here, 30, 0.3. So I tick here. So as because our the statistical table for matriculation will follow the format for px at least r, right? This format here. So as this is y less or equal, right, 18. So I have to convert become something in the form of greater or equal. So okay, this will be, if you follow the video one, you know that the video one in my lecture notes, you know that this is 0, 1, 2, up to 18, right? Up to 18. So you want from 0 up to 18, right? 0 up to 18, but you don't want 19 and above. 19, 20, up to maximum 30. How you know its maximum is 30? You see the sample here is 30, right? It's 30. So it will be up to 30. So doesn't matter, because they said y less or equal 18, means it can be 0, start with 0. So means I want 0 up to 18, but I don't want 19 and above. 19 and above. Everything here, total up everything, the probability will be 1, right? 1 minus with probability of at least everything, right? Because we start from 0. We start from 0. Is everything 0 up to 30 is 1. Is 1. So y at least we only want 0 up to 18, right? Less or equal 18. So we don't want 19 and above. 19 and above. So I should minus away 1 minus probability of y greater or equal 19. Okay, and now I can find the value here. 30, 0.3 for this distribution now. Now we find it about y. So at least 19. So where is 19? You see the value here. 19 is exactly here, which is 0.0002, right? 1 minus 0.0002, right? Which will give you the value of 1 minus 0.9998, right? So which will be 0.9998. Alright, this is the way we transform. So, okay, I give you more examples so that you have better understanding. So B, how about if I giving you that it will be at most less than 12, less than 12, right? Probability of x less than 12. Okay, this can't help you much because you know that the distribution x have a probability of success to be 0.7, which is not in your statistical table. So I should transform the variable x into this distribution with y so that I can use the statistical table. So, and I know that x plus y is 30, right? And x definitely is 30 minus number of failure. Number of success is the same as the total 30 minus with number of failure, right? So I can rewrite this to be 30 minus y. Probability of 30 minus y less than 12. Okay, slowly I'm doing. So 30 minus 12, you have 18, right? 30 minus 12, you have 18, which is less than negative y. Go to the other side. Y which will give you y greater than 18, right? Y greater than 18. So probability of y greater than 18, you know that our statistical table, matriculation statistical table, must be in the format of x greater equal. This is greater 18. So we cannot find the value of 18. We cannot just take, we cannot straight away 30, 0.3, then we find for the value of 18. No, this is incorrect. This is greater or equal 18, but now it's greater than 18. So the next number here, more than 18, will be 19. They want value of y greater than 18, means start with 19, 20 up to 30, right? Up to 30. So means they want start from y at least 19. This is the value that you're going to read from the statistical table, right? Same as this, 19. So which will be 0.002, 0.0002, right? That's the answer. Okay, more examples for this type of distribution. Okay, again, let's say if the question is asking you to find the probability of y in between, inclusively, right? In between 6, 15 and 20, right? Between 15, x, right? The value of x between 15 and 20 inclusively, right? So in this case here, so in this special case here, we know that the probability is not less than 0.5, is 0.7, which is not in the statistical table. So we have to do some transformation in helping us. So we have to transform the x into variable y. First, you have to know that x is 30 minus y, because x plus y must be equal to the total sample, 30, right? So x will be 30 minus y. So we have 30 minus y less or equal 20. At first, I should do this. Okay, later I need to have some knowledge for inequality, right? Inequality. So I have to minus everything with 30, right? Minus everything with 30. So 15 minus with 30, 30 minus y minus with 30, 20 minus with 30. My purpose here is to eliminate the 30. So it will become negative 15, right? 15. 30 minus 30, 30 minus 30, you have 0, then you have negative y. 20 minus 30, you have negative 10, right? Negative 10. So if you multiply everything with negative, with inequality, right, you know that you should change the sign here, right? Negative y, multiply with negative. So, alright. So, means that I can rewrite this to be probability of y in between 15, in between 10 and, right, greater or equal 10 and less or equal 15, right? So I can transform this into this form before I using the statistical table. So let's list out all the values here, right? All the values here. So you know that this is in your mind. Please don't write this in your working, right? This is just for me to guide you, so you know that it can be a value of 10. Start from 10, not start from 0, right? 10 to 15, 10, 11, 12, 13, 14, 15. This is all the value required, right? All the value required. 10 up to 15. Can be 10, can be 15. But you know that the variable will keep continue from 16 up to 30, right? 16 up to 30. The total is 30, so up to 30. If the total is 40, then up to 40. Doesn't matter. So, alright. So start with 10. This is the most important one. Start from 10 up to 15. I want, right? Start from 10. Sorry, it's y, right? It's y. Start from 10 up to 15. Up to 15. So I have to minus away something that is not 15. 15 and above 15. Okay, should include it. So I don't want start from 16, which is not inside the box. 16, start from 16. I don't want. That's why I minus. So and now I can read this value from the statistical table. Very simple. Okay, 30, 0.3. Look at this. So from here you can see that 10, right? 10. So 10. Where's 10? 0.4112, right? 0.4112 subtract with 16, right? 16. So it's 30, 0.3, 16. Where is the value of 16? Okay, 16. 0.0064. 0.0064. Then you will get your required answer. 0.4112 minus away 0.0064, which giving you 0.4048. Okay, the most important thing that you know what I want, right? What we want to deliver for you, which will be if you have a distribution which is not 0.5 and below, the value of probability is not 0.5 and below, that you cannot find from the statistical table. So usually we need to do some transformation. We transform become distribution Y. So which this is 0.7, this will be 0.3. The total probability must be 1, right? So because this is 0.3, we can using the statistical table, which you have 0.3. But at first you must know that X plus Y, the total sample must be 30, right? 30. So then you know that the X will be 30 minus Y, 30 minus Y. So everything here, if I want to using statistical table for this, there is no value 0.7, right, directly. So I have to convert this into Y. With the X, we write to be 30 minus 1, at least 12, and I do some transformation. Then finally, I can get the value from this distribution. Alright, this is what I want to deliver for you in this video here. So hope you understand.